All right, ladies and gentlemen, today we're going to start the first of a two-part process. Um, we're going to talk about converting a standard quadratic equation to a vertex um, equation, and then we're going to go from vertex to standard. So I'm going to go ahead and warn you, standard to vertex is a little longer process, not that long, but there's actually one more step than the other conversion. All right, so before you should have a foldable, and you should have folded it hot dog style, so you have the long way, so you have two sides. So when you open up the foldable, on the left side of the foldable, I need you to write standard to vertex. Now make sure you write kind of small, guys. Do not write big, because we're gonna have enough room to do our steps and 3 examples. And then if you do happen to write a little big, which I'm not gonna trip over, then you need to just write on the back of it. And as I told you in class, you will be able to use this foldable on the test. You can also use it for your school G assignments or any other work assignments we have. And make sure the work problems you're about to do, you want to do that as well. So underneath standard, I need you to write y equals ax squared plus bx plus c. Okay? Under the word vertex, I need you to write y equals a parentheses x minus h squared plus k. All right? So that's going to all be on the left side of the paper, the left side of your foldable. All right? So the first step, which is step 1, is you need to identify the values of A, B, and C, just like we did with the quadratic formula. All right? So that means all your letters and numbers have to be on the same side, which for our purposes they will be. And then they have to be in the right order. You know, your ax squared, bx plus c. Step 2, we're going to have a new variable called h. And the way we're going to find that h is we're going to say negative b over 2a. All right? So we're going to set it up as we're going to take the b we found in step 1 and the a we found in step 1 and divide the negative or the opposite version of our b by 2 times a, and that will give us our number. For our purposes, we will always have whole numbers, and they really won't be big numbers, but I do want to go ahead and tell you now that for our purposes, they will always be whole numbers and it'll be small numbers. However, this can work with fractions and it can work with bigger numbers, but for our purposes, they will all be small numbers. All right? Then we go on to step 3. Step 3 is we plug h into the standard equation to find the new variable of k. So if you notice with the vertex form, we have an h and a k. So those are our 2 new variables. And to find them, we're going to use step 2 and step 3. Lastly, with step 4, we're going to rewrite our equation, or the equation, with the values of A, H, and K. All right? So as I go through this, you'll see what I mean by that. All right, so again, like I said, make sure you write kind of small. Make sure you can read it, and make sure if you got a darker sheet of paper from Miss Sheffield, you make sure you write in pen. So, all right, so now let's go on to example number 1. All right, example number 1, our equation will be y equals 2x squared plus 4x minus 3. All right, so step 1 is to identify our A, B, and C. So we're going to say A is equal to 2, B is equal to 4, and C is equal to negative 3. All right, make sure if it's negative, guys, you keep the sign. And just like we did with quadratics, we only are concerned with numbers. We don't want the x's. All right, step 2, we need to find our h. So h, remember, is equal to negative b over 2a, so we're going to say negative 1 times our b, which in this case is 4, divided by 2 times our a, which is 2 in this case. All right? So now we need to just simplify. So negative 1 times positive 4 is negative 4, and 2 times 2 is positive 4. So we want to simplify this. Remember, I told you, for our purpose, they will always be whole numbers, and they'll be small. So negative 4 divided by 4 is actually negative 1. All right? So next, we're going to say step 3. We have k. We're going to change our y to a k, and say everywhere there was an x, we're going to put in negative 1. So we're going to say 2 parentheses negative 1 squared plus 4 times negative 1 minus 3. All right? So if you're going to put this in Desmos or either yellow calculators, all you're going to put in is everything after the equal sign to the right of the equal sign. So that's 2 times negative 1 squared plus 4 times negative 1 minus 3. And when you put in the calculator, guys, make sure you put the parentheses like I have in the example, because otherwise you're going to get the wrong answer. And it's very easy to get the wrong answer here. So I'm going to work it out because I'm not going to show you Desmos. So we're going to say 2 times negative 1 squared is actually negative 1 times negative 1, which becomes positive 1. And then 4 times negative 1 becomes negative 4. And then we bring down the negative 3. So let's go ahead and change this 2 times 1 times 2 to equal 2 and give us negative 4 minus 3. So if you say 2 minus 4 minus 3, well, let's do 2 minus 4. 2 minus 4 is negative 2 minus 3. And negative 2 and negative 3 give us negative 5. So that's going to be our k value, okay? So remember step 4. Step 4 was to rewrite the equation with the vertex form, which is on the right, as y equals our a, we said was positive 2. Then we're going to say parentheses x minus our h, which is negative 1, squared, and then minus 5, or plus k in this case. Now remember, your two negatives give you a positive, so we're going to wind up with our final equation being y equals 2 parentheses x plus 1 squared minus 5. All right, so that's our final equation for example number 1. All right, and I apologize, we actually have 2 examples here, so you just have to have room for 2 examples. I apologize. All right, does anybody have a question about number 1? If you need to pause the video at this time to get caught up, fine, pause the video, make sure you have everything written, and then keep on going. All right, so now let's do our second example. All right, example number 2. All right, this time I'm going to give you y equals negative x squared plus 2x plus 3. All right, so again, step 1 is to identify our a, b, and c. Our a is negative 1, our b is 2, and our c is positive 3. All right, step 2. We want to get our h. So we're going to say negative 1 again times our b, which in this case is 2, divided by 2 times negative 1, because that was our a. All right. Well, negative 1 times positive 2 is negative 2, and 2 times negative 1 is negative 2 again. So negative 2 divided by negative 2 gives us positive 1. So that's our h. So step 3, we plug in everywhere there was an x in our original equation. We're going to solve for k by plugging in a 1 everywhere there was an x. So we got negative, and then 1 squared plus 2 times 1 plus 3. And again, if you want to use Desmos or your yellow calculators, always type in everything after the right, everything to the right of the equal sign. Include your parentheses, guys. All right. So again, since I'm not going to switch to Desmos, I'm just going to write it. Well, 1 squared is 1, so 1 squared times, with the minus sign, we're going to put minus 1. All right, 2 times 1 is 2, and then bring down the positive 3. We didn't have to do the multiply. So now remember, we always go from left to right. So we're going to say negative 1 plus 2 is positive 1 plus 3, and then 1 plus 3 is 4. All right, so that's our k. And then lastly, for step 4, we're going to just plug in our values. So remember, our vertex form starts with y equals our a, which in this case is -1, parentheses x minus our h, which in this case is 1, squared, and then plus our k, which in this case is +4. All right? Now, you could leave it like that, and I'm fine with that, but on your test, what it's going to do is that digit of 1 goes away, and you're actually going to rewrite it as negative sign x minus 1 squared +4. All right, and that's your final answer. All right, so I'm going to stop here for this video, and this is just converting from standard form to vertex form, and I'll record a second video. I should be in class for this one, but just in case you're out or whatever else you want to watch it, that's fine. But thank you, and I'll talk to you in the next one. Bye.